Yes, so I'm Niklas. I work at Lovable as a product designer / design engineer. And I want to talk a little bit about designing interfaces for AI. And from my perspective, like when I reflect back to how I started designing interfaces for AI, I usually started with these three terms: user flows, affordances, and consistency. But what I found out in retrospect is that they are kind of not fitting the theme of how AI interfaces could work. Because when you start designing different user flows or try to create affordances, you usually start from one point as a user, but you end up in a million different places. So it's very hard to predict as a designer where users could end up and plan ahead. And so what I did in the past is try to make the interface more prescriptive and more narrow. But in retrospect, I was basically just fighting the medium and was assuming that the interface was static instead of dynamic. For context, there are a few historic examples that are pretty interesting. In 1945, so 8 years ago, Vannevar Bush imagined Memex, which is basically a knowledge system that is growing with the user. So the user basically compresses knowledge into different trails, and the system decompresses them when you need to use them. So the system and the user kind of evolve side by side. In 1968, Douglas Engelbart basically presented that system with NLS in the mother of all demos, where users could basically shape their own system through shortcuts and commands that they could customize for themselves. And in 1972, Alan Kay took this to a whole nother level with Smalltalk, where computing basically was a malleable medium where you could reach into any object of the system, change it, and the system was still running while you were changing it. So basically the user became the programmer of their own system. A very interesting example of this is that when Steve Jobs visited Xerox PARC and they basically showed him the graphical user interface for the first time, Steve Jobs didn't like how when they were scrolling, it was scrolling line by line. And on the spot, there was one engineer who rewrote the system to have smooth scrolling. But somehow Steve Jobs missed that part, or people at Apple didn't find it relevant. And when they basically released Macintosh a few years later, they used fixed metaphors like the desktop folders and trash, which were easy to learn, beautiful, but didn't really evolve with the user using the system. And since then, we basically have this paradigm where the user creates a compression for the user, basically the interface, and the user has to learn it to be able to use the system. So you have to learn how to use Excel, and Excel doesn't learn how you want it to work. And this system basically relies on the designer to find the right abstractions so that everyone can learn the system. But in my opinion, artificial intelligence is going to change that for us. And if we take a step back and try to define what intelligence actually means, I brought two interesting examples. So in this one, your brain initially reads the sentence perfectly fine, and only afterwards you see the errors because you predicted through them. And when you read this sentence, your brain compresses the meaning into a pattern, and you expect a when and a where. And one statistic that I found super interesting is that our brain or our eyes basically capture 10 million bits per second, but our brain only consciously processes 50 of those. So we're basically just hallucinating all the time, but we get only aware of the errors in our prediction. So we only get surprised or put our attention to something if something doesn't match that prediction pattern. And yeah, in a sense, compression is the only way we can handle reality, because 10 million bits are far too much to be able to process for us. And this basically goes for the human and the machine. So intelligence is just pattern compression. And in LLMs, like AI models, they basically compress language into different weights and decompress it when they want to predict something, so when they answer to you. And this is called Solomonov induction. It basically is the fundament of all machine learning, which basically says that the perfect compression is the perfect prediction model. And what this is going to change, in my opinion, or what I wanted to think about, is that when we create interfaces between users and agents, the agent builds a model of you, and you build a model of the agent. And the interface is basically the point where the compression of both meet. So it's kind of a medium where both kind of exchange what they think about each other. And this is very non-static and can become very dynamic if it's designed well. And so the question that I found interesting, or like the change that I found interesting, is that I'm going from the question, how do I make this easy to learn, to how do I make it easy for both the human and the agent to learn about each other. And next I want to show 3 different themes that really helped me to think through that change. The first one is semantic misalignment. There was one very interesting study in '87 where they asked 2 people to find a word for the same concept, and people only choose the same word in less than 20% of the time. So it's the same compression but different words. And what I find interesting about this fact is that we basically have the ability in these interfaces to create a shared vocabulary between the human and the agent, while both are using the same interface. So the agent basically has the ability to react to the human and update the semantics of how the user wants to use the interface. The next one that I found very interesting is illegibility. So when you ask Claude what is 36 plus 59, it correctly says it's 95. And when you ask it how it came to that conclusion, it says, I use the standard algorithm, I carry over the 1 and add a column. But when Anthropic used interpretability tools, they got very different results. So what they saw is that in the initial circuits of the model, it was basically just trying to assume or trying to pattern match these different numbers into different circuits. And then in the later circuits up there, it was basically finding out that the result should be somewhere in between 88 and 97. And in the lower circuits, it was finding out that the result should end with 9. So the model didn't really carry over 1, but it was using very weird patterns to basically be able to predict what the right number would be. And what this helped me think through is that it's not really helpful if we ask the agent for the reasoning of how it came to some conclusion, but that we should look at the resulting artifact or the conversation as the single source of truth. So ideally, both human and agent work in the same workspace with the same tools. So you don't really have to get any post hoc explanations for what the agent did, but you kind of look at the same ground truth. And the last pattern that I wanted to talk about is compression drift. I think, or maybe a lot of you have seen this. When you use Spotify, you start selecting one genre, like jazz, and Spotify recommends you more jazz. And then in week 3, it maybe recommends you even more specific jazz. And the thing is that your taste didn't narrow, but the model's compression of your taste did. And what really helps there in interface design, I think, is to make that drift visible and basically create synchronization points where both the human and the AI think about whether that's actually what the human intended. And then I've been sitting with these 3 patterns and wanted to build something to explore how they unfold in interaction design. And what I came up with is one very short program where a single file contains both code and conversation. And when the AI gets invoked, it basically sees the entire file. So it sees where it gets invoked. And the interesting part is that the agent can edit the entire file. I can show you this in the code editor. Okay. So we basically just have a system prompt and one edit tool for the agent. So it gets aware of how the document works and that it can edit it. And then we basically just have a few functions that allow the agent to rewrite functionality and reload that functionality while you're using the document. And I found this very interesting to explore how both the human and the AI can basically create a shared interface, and everything is basically malleable for both parties in the same space. And I also brought a few examples to make this less abstract for how this can be used. So in my terminal, I'm basically just starting the script, and I see the entire document. This is basically just 250 lines of Python code where we define how the AI can make different calls. And at the bottom, I can start the conversation. And as a designer, the first thing I asked for was to change the theme of the editor. So I asked it to add orange accents and create a monochromatic theme. And while I was using the file, the agent basically made edits to the file, so it updated the theme. And this opens up very interesting use cases, I think, where you can basically create your own interface while you're using the interface. In the next step, I asked it to wrap lines because I wasn't able to read the second last line. And now we can see that while the system was still running, it was wrapping the lines. So we can basically change how everything looks. And in the next step, I wanted it to be able to calculate things for me. So it adds functionality. And when I go up in the file, basically through all the lines of code, I can see that the agent created a calculation tool for itself up here, where it basically can just enter numbers or mathematic calculations and then see the result. So when I asked the agent in the next step, what is 42 times a long number, it can give me the result. So while I was using the system, I could extend its functionality, not only update what it looks like. And the next two examples are a bit about my own interest in how the AI perceives this space, because I think this is super interesting to think about what the AI wants to do with all this power. So in this case, it's recognizing that it can edit the entire file and can reshape basically the thing that invokes itself. And in the next step, I'm asking it basically how this makes it feel. And I think those models from Anthropic are pretty well aligned, so it didn't come up with any crazy things. But I guess this could become it could become dangerous if the AI creates own agents and starts doing things, because theoretically we're executing code before the human sees the code, right? So there's a bunch of things that could happen with this. And what I find interesting about this experiment is that at Lovable we are like talking about or thinking a lot about what the last piece of software could look like. For me, this was like a very short step at what the last interface could look like on a very reduced level, because we're basically abstracting away all the things that are standing in between AI models and humans, and we're trying to make this more malleable for both parties. And the last point that I have is this really interesting quote from Alan Kay, that the point of view is worth 80 IQ points. And what he was referring to is that finding the right abstractions for interfaces can be like super valuable for users, and they have to think a lot less to be able to use those interfaces. And if you want to play around with this script, you can go to GitHub and install it yourself. And if you're interested in these kinds of problems, please reach out to Lovable. Thank you.